Okay, so boys and girls, now I would like to give you the last session of chapter 8, okay, the analytic approach of Locus. So obviously, analytic approach, so if you still remember what you have learned in Form 3, we will say analytic approach means we put the figures into the coordinate plane. And then we have to use something like slope, distance, that means that all the things with related to equations of in coordinate plane to solve the problem. So we call analytic approach. So do remember is that when we talk about the analytic approach, as I just said, okay, we usually use slope, okay, SLOPE. And also sometimes we may have to use distance formula. Or even we have to use some formula, just like point of division. That means that we have to use all the formulas considering about the coordinate plane, okay, which we have learned in Form 1 to Form 3 to solve the problem, okay. But actually I would like to say this one is more easier than, okay, in a deductive approach, because you don't need actually to write so many things, or the figures, okay, that you can solve using the coordinate plane would be much more easier than, okay, what you have to draw, okay. But before, I would like to go through about this session, so it is necessary that we have to highlight what we have learned in chapter 8.2 in the last part. So if you still remember, as I mentioned in the 8.2 clip, I say that this one, okay, will be some of the things that you need to remember, okay, when we talk about the locus, for example, the straight line or the circle with some different conditions, some special conditions. For example, for parallel we can write in this way, and also you can see the B. This one will be a little bit special to you, is that, okay, if I make, okay, the area unchanged, then actually you know that because the base AB is fixed. With the area unchanged, it means that the height is also fixed. The height is actually the distance. That means that sometimes we will relate it to something like area with the fixed base, so you have to have the height equal. So we will have the distance equal also. Oh, sorry. And now, I would like you to take a look to the example 2 also. So if you still remember, I said the B, this one is very important. It is the very important that if you have the 90 degrees condition, then we will say that the 90 degree conditions of the variable point, if the angle, the 90 degrees exactly at the variable point P, okay, then we will say that it is a circle, because we have the theorem that we learned before is called the converse of angles in semicircle. So please remember that this one, okay, will be also commonly used in analytic approach to solve the equation of circle, okay, or the locus of about the circle. So please keep in mind this point. So now I would like you to take a look to see what 8.3 is actually talking about. We just say that, okay, what we need to do is that we have to describe, okay, the figure in the coordinate plane. It means that you will expect that the locus of P, no matter it's circle, parallel, or what, it is in form of equation. But this one will be more easier. Why? Because you have already learned the straight line equation, parabola equation, being quadratic equations, and also you have learned the circle equations in the last chapter. It means that what we need to use is that we have to use what we have learned the things before to apply in locus. So it's just very easy, because what you need to do is just you use all the chapters and then to go to this one. Okay, it's very easy. So now, but before we actually work on it, you have to keep in mind a very important idea, as I mentioned before. When we talk about the equation of any line or curve, okay, any line or curve in the coordinate plane, it just means that, okay, all the points that satisfy the line or the curve should have the relation expressed in the equation. It means that we will always say the point P, okay, the point P should be in form of x and y, and the equation is describing the relation of x and y, okay, according to the condition given. It means that, okay, what we need to do for finding the locus of the point P is just you have to describe the P as xy, and then we have to find the relation to right. It is also a very, very basic thing that you need to keep in mind, because when we start finding any locus, we have to say xy for P. For example, you can take a look at example 6. We say, now I have a fixed point A, 0, 2 in the coordinate plane, and P maintain the fixed distance from A. So no matter whether you have the coordinate plane or not, you should know this is a circle. Because if I have the variable point with the fixed point, another fixed point with the fixed distance, so you should turn around as a circle. But this time, okay, instead of you think about this one circle, you can also write in equation. Why? Because when we start writing the locus in equation, then we just say that P is in terms of xy. Then what we need to do is that we have to use some relation or some equation to relate xy to all the information given. For example, here I should use a distance formula, which is x subtract 0 square and then y subtract 2 square root, which is the distance between AP, or simply we say this one is AP. Oh, sorry, I should draw it better. For example, this one is simply the AP. Oh, very bad. For example, AP equals to this one, and actually now we have 1. That means that actually this one becomes a relation of x and y when we describe the equation. So what we need to do is that we have to work on it, and then furthermore, so you can see the book was just very easy to write is that, oh, you start with the equation, okay, the distance formula. So this is also the equation. After you simplify it, then you can see this one is exactly the equation circle. But it's not unfamiliar because you just learned before when we start talking about the chapter 7, when we talk about the equation circle, we also start from distance formula. It means that actually for writing the locus of the things, okay, sometimes we will repeat what we have done before, as I just mentioned. Okay, so don't think that it's very difficult. For example, the question 7 also now, if you have two fixed points, this time A and B, and we say this time the P, the locus of P, okay, maintains the equal distance from A and B. So you know that this condition, as we just learned before, we know that this one should give you the perpendicular bisector between AB. That means that if you join the AB, so you should expect that the line should be something like this, with right angle, and the same here. This is a perpendicular bisector. But how do we write this perpendicular bisector using the equation? So once again, because if you want to find the perpendicular bisector, so you may find the midpoint first. Okay, you may find the midpoint and then find the slope. But actually, you can also use directly the P, if I say xy, to form the relation, which we simply to say P equals to BB. Then what we need to do is that you substitute back and then you simplify until you have cancelled some of the similar terms. For example, x squared term, y squared term will be cancelled here. Then you just have only x, y, and constant. So it's not surprising because you understand that as I just drawn in the graph and also in the PowerPoint here, each is the perpendicular bisector. It's a straight line. So the equation should only have x or y. Okay, x and y, or x or y, and the constant. There should not be x squared, y squared term. So after you have simplified, you should expect the x squared term and y squared term should be cancelled. In order to leave the perpendicular bisector is a straight line here. But do remember is that practically in DSC, instead of using P equals to PB, we can also use some mixed approach. Mixed approach means what? Means that if I have seen the question and known from geometric property that we know this is a perpendicular bisector, we can also say the locus of P by using the geometric way. First of all, we can find the midpoint. For example, I say the midpoint. First, I use the midpoint formula. For example, this one it should be 0 plus 6 over 2 and then 9 plus 0 over 2. So for example, this one you should have 3 and then 9 over 2. Besides of this, then you can also know that the slope of AB, the slope of AB, for example here, the slope of AB should be equals to negative 9 over 6, which is negative 3 over 2. Then you should know that the locus P, this one, when we talk about the slope of this one, is simply you use negative 1 divided by negative 3 over 2 to get 2 over 3. Then what we need to do the last is that you have to take the slope of this one and this point to let you find the equation of the straight line, directly. So this one is called the mixed approach. It means that we are not directly use the condition given, for example, P equals to BB. But we first use a geometric approach or a deductive approach to understand that this locus is the perpendicular bisector. Then we find perpendicular bisector by using some special way. For example, I use the midpoint and also the slope of AB, negative 1 divided by perpendicular, to get the equation of locus P also. So do remember is that in DSC both approaches are accepted. That means that you can use mixed approach or just only use analytic approach, that means use the condition given to get the answer. Because you should expect that in DSC, we will ask you both the description of the locus, that means what is the name of the locus, as well as what is the equation of that locus. So you will see, okay, why we have to know all, because you can see many questions afterwards, no matter in Classwork or DSC practice paper or the DSC past paper, you can see we will ask you both things. Okay, so not difficult, but just remember to use, okay, the correct formula. Do remember is that we actually, no matter what kind, okay, no matter of what kind of locus, actually, as I mentioned, we usually use the following. For example, we have to use distance. Besides of distance, we will also use slope formula. Okay, so these two are very common for us to find the equation of the locus using analytic approach. And also, when we say the question next, now this time the locus P is fixed distance with equal distance with, okay, the point A, which is a point, and also the x-axis, which is a line. So you know that if I have the equal distance between the point and line, it should be a parabola, okay, the quadratic curve. But how do we work on the quadratic curve? So you can see this time we write the formula in this way. But actually, I would like to say that it is a little bit wrong here. Why? Because you can see in this question, we assume that P, the point xy, is in the first quadrant, which is the positive x and positive y. So you know that PQ should be y here. But do remember is that because originally we actually don't know where is the point P. Okay, for example, if I say the A is here, okay, the x-axis is here, okay. So as I mentioned before, you should expect that the curve should not cross the line, so it should be something like this. So you can expect that the P is somewhere else in the first quadrant, or also it may be in the second quadrant. But both, okay, in the first quadrant and second quadrant, y should be positive. Okay, so there's no problem that if I say the Q is somewhere else here, so I can say the PQ is just only equals to y. But do remember is that, okay, practically P, okay, sometimes may be, okay, below the x-axis. So when we say the PQ here, so do remember is that this one is no longer equals to y, but this time you should have negative y, because y originally is negative. So when we want to represent the distance, you should have a negative sign here. But don't worry is that because you have to take square, okay, on both sides in order to simplify the expression. So after square, both positive and negative can be cancelled. So y, you can see the book here, we write a positive y here. But practically, actually, we should write positive and negative y. That means that because we don't know actually what is it. So if you write positive and negative y, it is more correct than you just write y. But in this example, you can also write y. But no matter what, you have to put the square here. This time you can see that after you square, you leave a square term x squared here, which is x squared minus 4y plus 4 equals 0. But do remember that this one is actually the form with a familiar y. Because if we arrange y as a subject, we can write y is 1 over 4x squared and then plus 1. So you know that this one is a very okay, simple quadratic formula, quadratic equations with 1 over 4x squared, the a is 1 over 4 and the c is 1 and b is 0. Okay, so you are expected that, okay, because we first of all we may not know it is a parabola, okay, so we may write in the general form. That means that we put both x and both y or x squared together. But you can also write in another general form that you learned in Form 4 about the quadratic function, which we can write y, for example in this question, y equals 1 over 4x squared plus 1, okay, for this one. But you know that it should be a parabola. Okay, so you can see that, okay, the way that we have to write the locus is very easy. So what you need to do is just you have to use the condition, and then you let P be xy, and then you try to simplify the relation in order to say this is an equation for P. So we will call the equation should represent the locus of P. Okay, this is what we need to do. So as also you learned that, okay, I've just said that, okay, we have just learned the equation of some simple figures for our circle, parallel lines, or even parabola. So we will not ask you some complicated locus, for example, the circular track, okay, the running track, okay, before, because it's not easy to describe the running track using only one single equation. So don't expect that, okay, we will ask you this one in DSC. No, Very easy. We will not ask this in DSC, but we just ask you some simple figure, for example, like circle, straight line, including perpendicular bisector, angle bisectors, parallel lines. So all the straight line and also the parabola only. Okay, so you can see that even I go some example, you can see we will just focus on these three: circle, straight line, no matter angle bisector, parallel lines, and parabolas only. Finished. Okay, and then before I end the clip, so remember, as I mentioned, okay, we will ask you the mixed approach in the question. It means that I may ask you to use analytic approach. That means that using the slope or distance to find the equation, and then you have to get from the equation to know what is the name of the locus using geometric or analytic the deductive approach. For example, now you can see that for example 9a here, I first get the equation is x squared plus y squared minus x minus 6y plus 16 equals 0. Then you should know this is a circle. Why? Because we just learned in chapter 7, we know that this is equation of circle because you have x squared, y squared, and then x and y and then constant. So it should be circle. Then you have to also understand is that from the equation, okay, you can get all the information about this circle. For example, where is the center and also the radius. So you should remember to include these two information. That means the center and the radius for you to describe the circle in the part B. For example, you can see the part B said now we have to write the locus, okay, is the circle center at 4,3 and radius 3 here. But you can see there's a surprising step is that why the book would write this one where x not equals to 1 and x not equal to 7 is because that now you can take a look on the original question. You can see that this one, okay, this one. Now we have the P equals to BB. But P, okay, when you say it's a circle, it passes through the A and B. That means that now if you really draw the circle, consider about it, it should be something like this. But you know that when the P reaches no matter A and B, it will coincide. Then it is not defined to say PA or PB if the point is okay meet together. They meet together, coincide. So it's not okay valid to say PA or PB. So you can see the book, okay, in the solution will exclude this one. But do remember is that in DSC, okay, in DSC, this one is optional. That means that even you forget to write to exclude the point, it is okay as the answer. That means that we just need to write the equation. Even you haven't reject the point that coincide, we still accept this one as the answer. That means that this yellow part, okay, you can just omit it or just think that okay they can be coincide. Even PA and PB are not valid expression when they coincide, but you can still accept that it is okay for the locus. It's quite special in locus because you don't need to reject okay some of the things here. And also here also, if I say the locus of P inverse, so you have to excluding the A and B because you cannot coincide. But do remember is that in DSC, this part is also optional. That means that if you forget to exclude A and B, we still accept. Because in some of the ways, we have to use A and B also in order to complete the whole path of the circle. So you can imagine that if you just exclude A and B, then the circle will become something like this. A circle with two holes here. Okay, you have two holes here. But it's quite strange that the circle is not connected. You have two holes. It's a little bit strange. Okay, so in DSC or in some mathematical way that we need to do, sometimes we have to expect that we have to include the A and B here. Even it is not valid, but we still include it in order to complete what we want to have. Okay, so do remember is that the exclusion, okay, of the point that makes the sum of the expression invalid can also be optional. That means that you can still ignore writing this to writing the exclusion of this. That means that here you can write it or not to write it. We still give it the marks. Okay. So you can easily see that actually the exclusion of the point usually occurs in circles only, especially when we talk about the right angle movement. For example, if the locus of P is at the right angle, so when you go and go, then you will go near to the original two endpoints, okay, of the diameter. Okay, so you have to exclude it. But you can see another example, just like example 10 here, because they're parallel, so you don't need to exclude any points. Okay, so actually this one you can just read by yourself, very easy here. So before I end the clip, okay, so I would like to leave 5 questions classwork. Very easy, only very short classwork. for you as a practice. But do remember is that after this classwork, I have explained this classwork, I will give you a summary classwork. Summary classwork will be much more difficult because I will select some really the past paper of DSC question to let you see what really is going on when we ask this one in section B. That means we combine with circles, we combine with tangents, we combine with parallels, we combine with all the things in one long question. Then you will see how really the locus in the equation form, the analytic form, can be sometimes difficult. But for these 5 questions, just a basic skills for you. Try to do that, okay, and try to see if and see whether you have problem. Then you have to ask me, okay, later. Okay, so thank you very much for watching this clip. Stay tuned. Goodbye.